Hi, so this stack of cards was compiled to facilitate getting through the MCAT-style passage, qualitative analysis of contaminated water supply. It deals with the visible color spectrum a little bit. I think sp2 geometries, I can't quite recall, so let's just go through it. Yeah, so name this compound. Name this compound. As you can see, it's a bicyclic compound. All sp3 hybridization. So here goes the bridge. One cyclic, like a hexane looking thing. Another hexane in the, is that a boat conformation? Well, that's not the boat conformation. That's like the other. I don't remember what the trans conformation for hexane is. So it's two trans conformations for hexane join at a bridge. So what's this called? It's called cis-decalin because if you can recall, the hydrogens were both facing up. They were like cis to each other. So it's the bridge hydrogens were cis. So this is cis-decalin. So here goes an interesting one. Name this compound. It's 3 aromatic benzene rings attached to each other. So what's the name of this compound? I'll give you a moment to think about it. All right, so the name of this compound is anthracene. So anthracene, the image of anthracene is 3 benzene rings linearly attached to each other, okay? All right, this seems like a lot to handle, but it's just setting up the context for some solubility rules. The solubility rules state that halides, that's, chloride, bromide, iodide, not including fluoride, are soluble except with blank 2 plus, blank plus, and blank 2 plus. So what are the exceptions to the solubility of halides? And when I say halides, I mean these 3 things. I'm not including fluoride. So what aren't they soluble when paired with? So mercury, silver, and lead, okay? And there's an acronym called HAPB. It's in another set of cards, so just go to the series on solubility equilibria because it's related to this passage. The solubility rules state that hydroxides, OH negative, are insoluble with group 1A cations. Blank 2 plus, blank 2 plus, and blank 2 plus. So these are probably some group 2A cations or alkali earth metals. So group 1A cations are alkali metals like Na plus, K plus, stuff like that. So yeah, so these are some group 2 metals or alkaline earth metals. Ca2 plus, Ba2 plus barium, and Sr2 plus strontium. All right, so these are group 2 elements. And remember that you do have access to a periodic table on the MCAT, but it's just good to know these things for yourself as well. Strengthen your memory a little bit. All right, so the solubility rules state that sulfides, S2 negative, are insoluble except with group 1A cations, group 2A cations, and blank. Remember group 1A, that's Na plus, K plus. Group 2A, that's like Mg2 plus, Ca2+, Sr2+, strontium, barium. So the other one is ammonium, and the ammonium ion has an overall charge of 2+. And remember, ammonium is formed when ammonia, which is, a base, usurps a proton from either another molecule or just floating around in solution. Now this is a good question. What is the complementary color to blue? And on a color wheel, the color that's complementary to a specific color is going to be opposite it, not next to it. So let me just illustrate for you what I'm talking about. So here's a color wheel, like a pizza pie. Sorry for my janky pizza pie. Let's say this color were blue, okay? Let's say this were some blue. What color are you going to find over here on the color wheel? That would be orange, okay? That would be orange. And knowing this is interesting because I think if something shows blue, reflects blue, like in UV vis spectroscopy, it's actually orange, but it's reflecting its like complementary color, something like that. Just Wikipedia the particulars. But it's good to know the opposite or complementary colors on the color wheel.